Very good evening, everyone. Welcome to the series of the Great Amrita Alumni Conclave. Today, the millennials are more fascinated about the concepts of robots. Nevertheless, our childhood was inspired from the movies of Hollywoods like I, Robot by Will Smith, Terminator film by Arnold Schwarzenegger, and few years back, we had a Tamil film called Endran by Rajini sir, making the students a robot enthusiast. Even though those in the field of robotics, 80% of the students know about a Japanese robot called Asimo, created by the Honda company. Well, today we have an Amrita alumni who is going to enlighten us about the topic, my experience with the maintenance robot by Apuroop, who has pursued B.Tech in electronics and communication engineering from Amrita Vishwa Vidyapeetham. So before getting into the section, if any of the participants have any queries, please type it in the chat box. So Apuroop, I welcome you to the session. Therefore, we can start the series. Over to you right now.
Hello, everyone. Thank you so much for such a wonderful introduction. I am Apuroop, and I am really grateful and to be here today talking to such wonderful, enthusiastic students and coming from a vibrant community in engineering. And so today, my major intention was to mainly talk about maintenance robots and why did we go into this maintenance robots? Why not something else? So I can share my screen. Just give me a second. Okay. Yeah, I hope my slides are visible. Yeah. So a quick background story about who I am. I am Apuroop. I love to see that someday robots can help me serve my morning tea so that I don't walk up to kitchen to prepare my own tea. But it's going to happen. It's not impossible. It's going to happen, but in the near future. But before going there, today I'll be introducing about maintenance robots. And I give you a small scenario why the maintenance robots are quite important. When I was studying as a student and I was staying in one of the hostel blocks within Amrita University, our room motto is to be having a very good, clean environment. And also every week we used to spend a considerable amount of time in cleaning the space and also tidying up our room and all. So every time we do that, we felt like, oh, how come we used to do all this stuff, but maybe if we got some help, it would have been even more better. I don't know in what time we have thought about it, but somehow I came up to do research in maintenance robots. And we just don't build maintenance robots here at SUTD, but we build self-reconfigurable maintenance robots. I give a quick glance on how the self-reconfigurable robots work. Maybe you might have all seen the movie Transformers, where the robot change shape and they can convert into a car, they convert into a humanoid form, and then they start doing their tasks. In similar way, we have also come up with a few robots that can change shape while doing the intended task. So before even going, why robotics is a good question, because robotics market is gonna expand to almost size of $37.9 billion US by 2027. And I think with the adoption of more robotic solutions, I think this number is gonna be multiplied with several factors before even 2027. Why? Is because COVID-19 has become one of the catalysts in accelerating the adoption of cleaning robots. Because when everyone started to face the heat of lockdown and all, robots have come into play. They have kept people safe, the first responders safe, and adoption of these robots really opened up doors in terms of research, in terms of applications, among others. So here are some of the robots that you might have actually seen in the commercial market. The robotic community spans across multiple domains, be it cleaning, be it maintenance, be it logistics, surveillance, etc. There is a huge potential that is coming up. and many big multinational companies or even small startups, they all embrace robotics as a final end solution. And now good thing is that all the robotic solutions that are coming up is being embraced as a potential scalable commercial solutions. So as part of this, we have a few projects that I was involved in, and first project is Project Mine. And as part of this project, we have developed several robots, and this is the fundamental research that we were doing here. And we have anchored our research onto several platforms, and these platforms helped us to innovate even more things. I quickly take you all through some of the platforms that we have today here. H-Tetro is one of our flagship robots. As you know, there is a commercial cleaning company, several commercial cleaning companies, I should say, who have claimed that they have sold almost more than 1 million units. And but they proudly say that our robot can go and clean different areas within a house, and it is so good. But the problem with those robots is that they all come with fixed morphology. That means fixed shape. They cannot change shape. Then what happens with such kind of a robot? So here we are addressing that kind of a problem, which I will be showing later. And we have drawn inspiration from classic game Tetris. We all grew up playing that game, and so the research inspiration was also driven from that. And we have built a robot that can change into 7 different shapes. As you can see in the current video, the robot that you see is a commercially available cleaning robot, and the setting is a typical office setting. And as you see, this robot cannot reach tight spaces. But what is the immediate and major contribution that a cleaning robot can do? Cover as much as area as possible. But the preliminary requisite itself, this robot is failing. Then how do we address this problem? So here we have deployed our H-Tetro, which is a Tetris-inspired self-reconfigurable robot. It can change shape to go into tight spaces and then clean efficiently. And we have also performed several experiments over this particular robot to assess the area coverage and also to plan different paths in a more efficient manner. So here is one of the quick glimpse on how the robot is covering the area. The green color is the area covered by the robot. As you can see, the robot cannot move from one side of the chair to other side of the chair, which is typically observed by the commercially available cleaning robots, which are of fixed morphology. But here comes our robot, which we have developed. This robot can seamlessly change shape to move from one side of the chair to other side of the chair, thus enabling 100% area coverage. So this is something that we are currently working upon, and several research papers have been published in top tier journals, proving the capability and efficiency of this particular platform. As an engineering point of view, it is quite important and complicated to plan the path to let the robot know how it has to go from one area to another area without compromising the area coverage efficiency. So this robot is also currently being tested at several food courts, and we are looking more towards further deploying in a few other places. So then usually, right, there is always this particular claim that these cleaning robot companies make, where they say, hey, we have embedded a lot of sensors, a lot of intelligence into the robot to make sure that it can detect the stairs and prevent itself from falling off the stairs. Right? Technically, wow, it sounds super good. But who cleans the stairs? The question comes, right? Who cleans the stairs? That is where we have took that opportunity. It is not just a horizontal, but we are looking at XY plane where we can go and clean. So this robot has inbuilt AI models which are developed that can detect staircase, aligns itself with the staircase and starts cleaning. As you can see, this robot has 3 movable parts. It can, as it moves, it changes its shape from fixed morphology to movable and reconfigurable shape. then this can just go up, clean, and come back after the cleaning. It can come and dock itself into the charging port. So similarly, several research journals have been published on this particular technology, and research is still going on in terms of improving the safety and detecting the more complex staircases and planning the path in the 3D plane. So we have not just limited to the floor and the staircases, but we have also went an extra mile on something else. That is nothing but a glass facade cleaning robot. Why is a glass facade cleaning robot important? Is because, yeah, even now the building owners and the facility managers are adopting glass facade designs more and more often, and this opens up a huge laborious task for the humans to go up and clean every time, and this also poses a serious safety hazards if proper safety measures are not taken. So in this regard, we have developed a reconfigurable robot that can seamlessly clean on the glass panels. You might have also seen some of the other robots in the market that can clean a glass panel, but those robots have a limitation of moving from one glass panel to another glass panel. But here, as you see, the robot leverages upon the self-reconfigurable principles that are developed to seamlessly shift from one glass panel to the another glass panel, right? And we use active impeller mechanism to create enough suction power for the robot to stand on the vertical surface and then just go. Is it just the cleaning that we do? No, it is not just the cleaning we do. Because the platform is quite strong and stable enough, we also embed the AI capabilities into it. But maybe people might just think, hey, how come AI capabilities can come into this? But we are looking at not just cleaning. For example, let's say there is a cleaner who is cleaning the glass panels and suddenly he observes something, a defect in the glass panel. Then what does he do? Will he just leave the glass panel like that, cleans and just go? No, right? He goes and reports or inspects further. So the similar analogy has been used here. The robot not just cleans, but also looks at further defects such as cracks in the glass, and using deep learning models that are trained, and it can go and report the robot supervisor accordingly. So it is not just the facade cleaning that we have done, but we have also leveraged this particular technology in aircraft maintenance domain. Why aircraft maintenance domain is a similar reason. The hull of the aircraft have to be tested or inspected at a frequent basis. And that is how the technology that has been developed for the glass facade has been further leveraged to come back onto the aircraft inspection application. One of the key requirements or challenges is that the robot needs to transition automatically and seamlessly from the wing to the hull. So this, the control or the planning algorithms and the mechanical integrities of the robot have been seriously tested and have been successfully delivered to the corresponding industry partner. So this also has been tested on real aeroplane, and we have also used the deep learning models to detect different types of defects on the aircraft, and then we report the same to the robot supervisor. Yeah. Then the next one is about another cleaning robot, which is nothing but Panthera. Panthera is something very interesting because Singapore has a vast and a large network of pavements, and it is quite laborious to clean the pavements and keep them in maintenance for on a constant basis. So robot such like Panthera can be helpful in cleaning the given pavement. But how come it is different from the existing pavement sweeping robots to machines to robot is that this particular robot can shrink or expand its size based on the obstacles. So for example, let's say there is this person who's a pedestrian who's walking, then the robot can compress and expand itself according to the pedestrian's movement. So the engineers and the researchers have worked on building the control algorithms, and also to come up with the mechanical structure designs and everything, which further adapted to provide proper autonomous navigation stack. As you can see, even if there is an obstacle, the wheels adjust themselves based on an active feedback loop, and they perform the navigation seamlessly. So this is a small video that shows the compression and expansion capability of the robot. Currently, we are moving towards another version. And as you know, this robot is holonomic. That means it need not change the orientation, but can move on the plane without changing its orientation. Yeah. So we have also used several high range sensors like 3D LiDARs, and also embedded with a few other sensors like IMU and all, to further fuse this data to have a proper stable navigation stack. So the deep learning models have also been generated to detect a person and compress accordingly. Yeah. Then next comes Scorpio. Scorpio is quite interesting because it has been the robot has been inspired from a specific species of spider that can roll, crawl, and climb. So why we have developed this class of robots is for major purpose is to have urban reconnaissance. This has been developed as part of the project awarded by Department of Defense in Singapore, and the major requirement is that the robot has to be deployed and stay there in a given place with a single charge and run for almost 25 days without replenishing. So the major idea is to also crawl, roll, and climb by changing shape. So as you can see, here is a quick example of how the robot can climb glass panels. This can be used when the robot needs to climb over the buildings, and also the robot can change shape to roll quickly, and also it can crawl to minimize to reduce the attention of this from the people from the surrounding. Yeah, it also has a lot of error recoveries, and the behavior has been further fine-tuned over certain long-term deployments. And so these are few robots that we have. And why we have built all these robots is to show the strength of the application domain that the cleaning, maintenance, and inspection have. And these are some of the examples of the robots that are developed. It is not just that we develop and leave, but we also attract enough companies to license this particular technology from the university to take it up as a commercial product outside. So our research is not just limited into between the four walls, but it is also going out as a commercial product. The next project is Project Toucan. It is on the pest control domain. As you know, if you see the images, right, this is how usually the pest control is done. And the image on the left shows the fall ceiling inspection, or the cleaning of the fall ceiling. The most common pests that are found in the fall ceiling are like rodents, cockroaches, and a few other insects. So it is quite hazardous because of the fumes that are just stagnated in that closed fall ceiling for a very long time for a human to enter and start cleaning. And also on the right side, if you see the drain inspection, that's how a human usually does the drain inspection. And it is also quite dangerous because the drains are constructed over for a very long period of time, and it is quite difficult to know where is the breach in the structural integrity of the drain. And so there is a problem statement. So we have come up with solutions in terms of robots being deployed. And the two solutions are Falcon and Sparrow. Falcon is a fall ceiling inspection robot, while Sparrow is a drain inspection robot. They are leveraging upon the self-reconfigurable principles that have been developed in the Project Ermine as part of the fundamental research. So first one is Falcon. It's not the Marvel character. It's our fall ceiling inspection robot. And as you know, fall ceilings are quite tight spaces, and it is very important to have focus on the size. but not compromising the functionality. So we have developed several versions of the Falcon, which looks at different types of ceilings and addresses the problems. So we have developed Micro. Micro is for tighter spaces. So we have recently deployed this robot in one of the ships under Singapore Navy to inspect their false ceilings. And it is not just inspection, but the robot has the capability to transmit video images from the onboard camera. So we are all using low power computing systems to transmit the image data. So this is a quick example of the false ceiling inspection within one of the test areas. And as you can see, there is a lot of, it's kind of a tight space where I think humans cannot easily go in. So robots help the human operators to further identify where is a problem and how the structural integrity within the false ceiling is. Then the next one is the fetch. As you know, fetch is quite important because it is not just inspection, but it also shows what we have done after inspection. So as you see on the video on the left, some of the beans have been replicated as rodent droppings, and the robot easily go and fetch all the rodent droppings. And the second one is going to dispense the bait. It not just collects the rodent droppings, but it also dispenses the bait. Why? Because as the user cannot go to the false ceiling because of tight space, the robot can take the pesticide or the rodenticide to go to the point of interest, and then at just the click of a button, the robot just dispenses the pesticide. So as you have seen, it is not. Then comes a question, right? Hey, how come you know the point of interest? If I start walking in a huge shopping mall, I sometimes lose my way. Then how come I get to know where my robot is within the ceiling, false ceiling? Then that is where we have developed a positioning system where the robot can be easily identified where it is present within the false ceiling. As the robot moves, as you can see in the video on the left top corner, the robot is shown on a real-time basis as it moves, and this can help the navigator to further precisely control. And if in case the robot gets stuck somewhere due to some other reason, the robot operator can just climb up to open one of the false ceiling boards to retrieve the robot exactly, instead of searching the whole false ceiling. This has been tested at one of the test bedding sites that mimics the mock false ceiling. So it's not just that we inspect and detect and deploy the pesticide and come back, but we also look at other leveraged applications. Like, let's say there is a wall within the false ceiling that is having a structural defect, or there is a pipe that is causing a water leakage, or there is a degradation of the electrical wires. So the robot just not looks for the rodents and the other pests, but it also looks at the structural defects or other types of building management issues. So we have developed several deep learning models to detect these type of structural defects. So as you can see, and one interesting thing is that the robot also detects the type of rodent. We have trained it's a mock rodent. So we have trained the model to detect the rodent if it walks past the robot. So the robot can also be deployed overnight. It can stay there for almost like more than 12 hours on a sleep charge, but can get woken up by any movement. Let's say if the rodent just passes by, the robot just wakes up and takes a picture to further show the robot supervisor when he or she returns back to the work. So it is not just we design the robot, we also look at user experiences. As a researcher, it needs to be a comprehensive and a holistic view of what we are doing. So we have improved the packaging into a better way so that people can carry easily. So we have addressed the ergonomics problem here. Then next comes is our drain inspection robot. Our drain inspection robot usually is deployed in the drains for few applications. One is to inspect the structural integrity of the drains. Two is to collect the water samples. Three is to deploy the pesticides. So as you see here, right, the robot uses the reconfigurable principle so that it can be manually reconfigured to change its shape in terms of width to fit different types of drains. And also it is easy for a robot operator to just change the shape. So we have also embedded several sensors that has potential to capture all the required information, such as the cracks in the wall, the collection of the sample, and also if there are any tree roots that are protruding into the drain, it can also try to overcome those obstacles using a specially designed mechanical drive system. Yeah. Then these are some of the videos that we have taken during a real life deployment in the trains. The robot goes on those side tracks, and it can also take turns if there is a turn within the drainage network. So as you can see on the video on the right, there are two pipes that are just hanging on top of the drainage water. It is quite interesting because these two pipes collect the water samples so as to stop the breeding of mosquitoes. So whenever there is whenever these samples are collected and later sent to the lab for further processing, and then immediate action can be taken to prevent the further breeding of mosquitoes. It is not just we have developed the robot, but we have also given enough considerable design considerations to operate the robot underneath the drain, where the signal reception strength is quite low. So now currently we are moving towards adopting other communication technologies like 5G to further propel the flexibility in operating this particular robot. So as you see, this is how the robot is being controlled. The operator can use a joystick to turn, also to move forward, backward, and this video feed can be later collected within the robot and can be used for further post processing and insights. So as I've mentioned, the video on the left shows that the samples are being collected on some of the test tubes on the robot. And once the samples are collected into the test tubes, they are further transported to one of the laboratories where the testing happen to detect if there is any breeding sites, if that particular drainage is a breeding site for mosquito. If let's say the result has come out, the operator can use the same robot on, just like as shown in the video on the right. It can dispense the pesticide or the other related rodenticides or something like that. So this is the overall overview of the robot, where it can both collect as well as dispense. So we have also used the data models based on deep learning neural network architectures to detect the stagnated water. Why we need to detect the stagnated water is because the robot can automatically go to such kind of stagnated water to collect the samples, because usually the stagnant water are the good breeding sites for mosquitoes and other pests. So it is quite important to detect the stagnant water. So coming to this, I also wanted to tell how Amrita University has shaped my career and how it helped me. So I joined the university in 2014 under the Electronics and Communication Engineering discipline, and I have attended several design camps and bootstrap events in 2015. And later I joined as a student researcher in Humanitarian Technology Lab And from then I started working on university funded projects, and I have got considerable exposure in terms of both technical as well as managerial. I also got the opportunity to publish research papers in international conferences and journals under the supervision of Professor Dr. Rajesh Kannan Megalingam. And this has further improved my managerial skills, because I was also part of the IEEE executive committee, and we got a chance to organize several events along with the research and development. So then these all combined together helped me to get an admission in a dual master's degree, and I was successfully able to use those experiences to pursue my degree and graduate from there at SUGD. So career opportunities, there are a lot of opportunities. The world really needs you. After I have shown these many robots, you must have understood the gravity of the requirement that this particular industry have, and also the strength of the potential strength that this industry can project into the future. So there are several research options, as well as industry options here in this particular field. As you know, by end of 2021, there are like 3 million industrial robots running all around the world, and I don't think there are enough people to even run these robots. But there can be one question. There is a popular debate that always goes on. Does robot take away our jobs? Does AI take away our jobs? And if there are 3 million robots, would we start losing the potential opportunities into this? I would rather say that the jobs are not lost, but they are transformed. It is like once the laborious task or the hazardous task to the human being can now transform into becoming a robot supervisor, where one person can control 2 or 3 robots and manage those 2-3 robots while doing more meaningful job in the later part. So it is not also wise to say that all the jobs are lost, but it is something analogous to, let's say, there are the invention of calculator never replaced a chartered accountant. Rather, they just empowered the chartered accountant to become even more efficient. And computers have become made that 100 times more possible in terms of efficiency. So robots should be considered in such a way where they help us develop and become more efficient, rather than considering them as a means of replacement for the human jobs. So as I've mentioned, there are several career options. There is, if you consider autonomy engineer mainly focuses on handling the navigation and path planning strategies for the robot. That is, for example, I can give you a situation where you went to a new place. Let's say you went to London, and you have not known the place because that's your first time visiting. And here you would like to find out a way to maybe one of the good sightseeing spots. And how would you find your spot? The way you can find is using Google Maps. Let's say you don't have Google Maps, then you need to rely upon your sensory inputs like visual, audio, and your motion, etc. So using these senses, you would start finding the way to go to such kind of a place. So the robot also faces a similar issue. When you deploy it in an unknown environment, it doesn't know what to do. So usually they create a map, and they feed the robot with a map. And then on top of that, they have several layers of navigation stack that fuses the information coming from different sensors. And then it gives a meaningful insight on where the robot needs to go. And also it will also tell where the robot is there within a given environment, so that it can better understand its own position, so that it can plan its path to its destination. So this is a very brief job scope of autonomy engineer. And coming to embedded engineer is something similar, because constructing a robot is not just a single man's job, but it is a culmination of all the disciplines coming together. So embedded engineers build systems that are so nimble and can also easily fit into robots. Let's say you are looking at a robot that is very small. In our case, it can be the Falcon Micro, where it needs to go to a very tight space. In this case, there needs to be a very good process manufacturing and a good design, including the optimization considerations to create an embedded system. Then comes the mechanical engineer. Mechanical engineer is obvious because they have to design a proper structurally having a robot that is structurally viable and also maintains its integrity. So there is a lot of scope for mechanical engineers as well. And validation, full stack developers and reliability engineers are all who comes on the testing part, where they would make sure that the robot is of a given standard and they meet all the requirements of a said problem statement. It is also important that not only just autonomy or other core development engineers are required, but it also opens up doors for several people like cloud architects, industrial designers, vision engineers, AI developers, etc. Because they have to build a full-length system to control these robots. If let's say there is only one robot, we just use a joystick or something to control. But let's say a company is deploying hundreds of robots or 200 of robots, then how would you streamline all the processes that are there within this particular company? So there needs to be a workflow methodology that has to be defined, and these are all robots have to be connected to the cloud. One good example is that it can be like an edge computing, where some special features can be stored on the cloud and can be accessed on demand, while other features have to be on the robot. For example, let's say the obstacle avoidance feature needs to be compulsory be on the robot, while a speech module can be on the cloud, and whenever the robot needs to talk something, it can go and fetch the service on demand. So it is not just the engineers, but robotics is open for other people as well. How is it open? One of the core area that we are working towards at SUTD is to democratize the design in the robotics industry. What do I mean by democratization of the design? It is nothing but we are looking at three pillars. One is design of robots, design by robots, and design for robots. And within these three, design of robots is nothing but you have a problem statement and you start designing it, designing a robot for it. That is design of robot, which many of the people do. And design for robot is nothing but you design the spaces or the places that enables the robot to go around freely, right? So for example, let's say many of the buildings are wheelchair accessible or accessible by people with special needs. So if the buildings are accessible by people with special needs and the designs have happened to accommodate that, and as the industry is moving towards adopting more and more robotic solutions, it is also a good opportunity to redesign the places or the buildings and the spaces to accommodate these robots. For example, I give a quick example on why this is important. Let's say there is an office that is partitioned with the glass panels, and there is a cleaning robot that has to be deployed there. As you know, the LiDAR sensor, which depends on the light pulses to find out the obstacles or find out the place, find out its own proximity to the obstacles, fails because the glass never reflects. So what happens here is that you need to put another sensor, which usually be the sonar sensor, and you need to fuse it with the existing LiDAR to find out where exactly is the obstacle. What happens here is that as the complexity of the place increases, you need to keep more and more sensors into the robot to let it know that it has to let it know where it's exactly located in the given space or how it has to avoid an obstacle. In this regard, right, the commercial viability of the robot just decreases. It means that the robot becomes more and more expensive, and people cannot usually accommodate it. Then that is why if we can come on the other way around, if we make the buildings more friendly, accessible, then it will be easy for the robots to house less sensors to perform the same given task with increased efficiency. So this is designed for robots. Then the last one is designed by robots. So the design by robots is nothing but the principles that are generated within the design for robots is used as a service. It can be said like these principles can be fed into another robot, where the robot can manage or redesign the spaces. For example, let's say I have shown a cleaning robot at the start of the presentation, right? The cleaning robot couldn't go into the tight space. Then what happens? This particular robot supervisor, who is already fed with the principles that are developed under design for robots, can go in, analyze a given space and say, oh, this chair need not be here. This chair have to be moved out so that the cleaning robot can easily go and clean. So this is something that is called design for robots. Designed by robots. So this is what we are looking at, democratization of robots. Along with that, we are also having a few architects who are working in making the buildings more robot friendly. So it is not just the engineers or the technical people, but we are also housing architects to make the robot ecosystem more friendlier. So all the research that is taking place at our lab is headed by Prof. Mohan Rajesh Ellara at SUTD, and we are currently the global #1 at in the terms of reconfigurable robots. And my personal suggestion to all the engineers or aspirants who wants to join any of the industry, need not be robotics, but any industry, is to follow the 3 steps. One is to ideate, look around for the problems. No, if you start looking for the problems, then you will be getting a source to solve and design. To design and model a particular problem, you need to look at the nature, because nature has done the most of the job for us, because it has optimized almost every living being and every process within the universe. So nature is a perennial source for inspiration. Just look at the nature and you can draw almost any solution to your problem and then deploy. Just don't build the robot and leave it, but try to deploy it in real field. Try talking to people. In this way, you will also get the managerial experience on, and also you can build your soft skills. So it is not just building the robot and letting it go, but you have to also test it and redesign and ideate again. So the process just continues. So as part of the conclusion, it is important that to understand that AI and robotics will elevate the jobs. They are not a replacement, but they help to elevate the jobs. And training and reskilling will be necessary. Definitely, it is like when cars are invented and are sold in the market, people had to learn how to drive. So it is similar to something like when we have bought the cars, is same analogous to when we buy the robots as well. Also need to stay in line with the current industry trends. It is also important to find out what is happening in different places, and also with the current geopolitical conditions, opportunities just come up and are just hidden in a plain sight. So it is our responsibility to find out those problems and try to address those problems, and also think futuristic while adhering to the value of the application. It is something like the humanoid robot is a very good, exciting research possibility, but it doesn't hold much of the application value, whereas it is too futuristic at the moment. So you need to still anchor yourself to the value of the application in the near future while thinking futuristic. So that helps you develop the vision for your own robot. And there are lots and lots of emerging opportunities in the world. COVID-19 was just an accelerator. It helped people and companies to adopt more and more technological solutions. And you should always remember, only during the times of adversity, the innovation happens. So we need to really take this as a challenge to improve our community and work towards building a better place in the world. So as a robotics AI engineer, you have to define what problems you want to solve, and the university will be a catalyst in pushing you one step towards your goal. So Amrita University has really helped me in shaping my career. If it is not for Amrita University, I wouldn't be pursuing robotics. And the curriculum, the holistic education that Amrita University has provided me really catapulted my career into positive growth trajectory. And I was able to learn much of the stuff because of the strong research centers that they have. and also the friendly professors who always encouraged us to push our boundaries so that we deliver the best. And as I've mentioned, always, even though we are developing robots, our core value lied in helping people. So we always looked at the humanitarian aspect of why we are developing the robot, and how this particular robot can help people in the times of distress. So all these things really help me to shape myself, and currently I'm really proud to say that I'm an alumni from Amrita who have come all the way till here, and making change, significant change towards the robotics community. Yeah. So I would like to thank Amrita University for providing me this opportunity to speak during this event, and National Robotics Program Office and SUGD. And I would like to thank my professor, Mohan Rajesh Ellara, who is currently supervising all the research at SUGD. And also I would like to thank National Environment Agency, who helped us to deploy all these robots and collect valuable user feedback from different test sites. Yeah, thank you so much. You can, if you have any questions related to anything, you can shoot your emails to my email ID here, and I would be really happy to help you out, be it career guidance or be it any technical advice. Yeah, thank you so much.
Oh, that was a great seminar from you, Apu. So we have a question from one of our, we have a question from one of our participants.
Okay.
What specialization in MS shall we take after BTech robotics?
So this is quite a common question that I usually hear. Even when I was taking my master's, I was looking at what could be the potential avenue. But after your BTech, it is, as you grow in the degrees, your focus gets more and more sharper. So in BTech, you learn most of the stuff. You get the view of the horizon. And as you enter into masters, you try to refine one of the skills. You define a direction, and then you start going. And once after you finish your masters, you'll get into PhD, and the focus will be even more finer. Why is because only if you focus on one thing, then you can develop and contribute a significant change to the research community, in turn making a significant change to the commercial market. So after bachelor's, it is important to go and analyze the universities. What programs are they offering? How is the research standing that they have? And for example, Amrita has a strong research standing in terms of international journal publications or the centers of excellences, etc. So you need to look at universities that have this kind of strong research standing, and that would help to propel your career further. And mainly importantly, you need to look at the domain that you want to go. So only you can answer that question, which domain you would want to choose. Don't associate yourself to a product, or don't associate yourself to a particular degree, but associate yourself to a problem. If you associate yourself to a problem, then you would do whatever required to do that. If you would have to learn the cloud systems architecture, you will learn that. If you have to learn mechanical engineering designs in mechanical engineering, you would learn that. So associate yourself to a problem. The problem can be anything. You want to solve the cancer problem, you want to solve food hunger problem. These are the problems that you have to associate. I am associated with a problem that is mainly focused on helping humans from doing laborious and hazardous tasks in maintenance, inspection, and cleaning domain. So I'm moving in that trajectory. So I would also like to suggest to find your own domain of interest. Yeah.
Okay. This question is not that much specific. Maybe he's thinking, is there any dual degree course for robotics?
Yeah. So there are several universities offering dual degree courses that can help you. Like for example, within the masters, I mean, it's still like it's a wide range of spectrum of the courses that are available online and with universities. So for me, I know SUDD offers a strong curriculum, just like Amrita offers in their masters. So you can give it a try at SUDD. Because the focus is also very good, and yeah, so it can be done. Yeah.
Okay. Okay. That's it. Thank you all the participants. Thank you once more. Thank you, Apoor. And let's call it a day. Thank you.
Yeah. Thank you so much for inviting me. Thank you.